I'm going to solve how to reverse words in sentence. The input of this question is all the words of the sentence. The output of this question is the reversed version of the sentence. I'm going to assume there is no extra spaces at the heading and tailing of the sentence. And second of all, I'm going to assume each words have only one single space to separate them, so which is in between. So third of all, the input is not none. I'm going to use recursion function at one and in place space to solve this question. And how I'm going to do that? First of all, I'm going to convert string into char array, so we can make sure there's no extra spaces will be used in the recursion function. I'm going to show you an example to demo how this recursion function gonna solve the problem. Let's see, if we set the sentence like I love Google, the output we're going to expecting will be like Google love I. And step one, what I'm gonna do is I'm going to reverse each character of the original sentence. So which means we're gonna reverse the whole string. Let's make a copy of the original sentence, and then I'm gonna set integer left and integer right. So integer left will be pointed right at the beginning of the sentence, and the integer right will point it at the very end of the sentence, which is E over here. So in that way we can determine the integer left will point at 0, and then the right will point array that length minus 1. And then we're gonna swap left and right. So after swapping, like the first one will be like I swap to E, and E will swap to I, and the space over here in between will swap to L, L will swap back over here. So we're getting the result like E, L, G, O, O, G, E, V, O, L, and I. So this is the result after step one. So once we get this sentence, we're going to move to step two. So what I'm going to do in step two is reverse each words of this sentence. Reverse each words of the sentence. So in here, I'm going to set start and the end. The start we're going to representing the very beginning of each words. The first one will be E, second will be E, the last one be I himself. The end we're representing the ending of the each word. In here will be G, and the second will be L, the last one be I itself. So it's clear you can see, and also I mentioned that from very beginning, we're assuming there is no spaces and heading and tailing. So the integer I, we're never gonna be the space. There are never going to be empty space. And we have to also make sure that start will also point at index 0. So we're going to start from very beginning. And then will also possibly happen to the second case. So or when we move it to the second word, like here in E, as you clearly can see there is a space before the E. So we just have to make sure array start minus 1 is equals to a space. So that's the case 2. So how we're going to determine the end? As also I mentioned in the beginning, there is no space at the heading and tailing. So the end will not equals to a space. So, and also we have to make sure we're gonna go through the full sentence. So end will stopped at here at I. So I will be the end of it. So equals array dot length minus 1. Or there will be a second case, which is when end, move it to the first end of the first word or the end of the second word. As clear you can see array end plus 1 in here. So g plus 1 or equals to a space. Oh, space. Okay, so after this, we're just gonna reverse array and start and end. So we'll be in here. I'm gonna show a demo over here. So we'll be GOO, GLE, LOVE, and I. So that's how we're getting the result from I love Google to Google love I. And I'm going to show you the code of this question. So over here, oops, sorry. So it will be like this. This is my coding. Like I mentioned, I convert the char array of the string to jar array and using a helper function swap swap, helping us to reverse the full characters of the string, and then we kind of move to step 2, which is reverse the each words of the sentence. And then the time complexity of this problem after this recursion function will be O(n), and then the space complexity we made sure in the beginning, so there's no extra spaces for you, so it will be O(1). That's how I solve this question. Thank you.